This is your graphical problem. So they're telling you that this is the graph of f that's given. And they define g as the integral of f from -4 to x. So they want you to find these three values. Okay, let's start with g of -1. So all I'm going to do is take this definition they've given me, equation, replace the x with -1. So I get g of -1 is the same as the integral from -4 to -1 of f of t dt. I notice that the graph is constructed using line segments, so I can do this geometrically. So it's just the area of that trapezoid right there. But I also notice that is below the x-axis, so you need your answer to be negative. So negative, area of a trapezoid is 1/2. The base of that trapezoid is 3. I'm sorry, the height is 3. The two bases are 2 plus 3. So I get -15/2 for g of -1. Now they also want g prime of -1. Well, this is your second fundamental theorem. If g of x is the antiderivative of f, then g prime of x undoes the integral symbol, the x goes in, so g prime of x is the same as f of x. So g prime of -1 is the same as f of -1, which is just the point on this graph, is given as -2. G double prime of -1 would then be the slope of f at -1. I notice at -1 there's a corner, so the slope of this graph does not exist. Okay. Part B. It says find the point of inflection of g. So as soon as you see those words, you should be thinking about g double prime, but you need to connect it back to f. So I'm thinking that g double prime is the same as f prime. So you're looking for where this changes signs. So look at the graph of f, and where does f prime, which is the slope of f, change signs? Slope here is positive, positive, then negative. So the only place where the slope is changing is at x equals 1. So the answer is x equals 1. And you can say because slope of f changes signs, or you can also say because g prime, which is really f, changes from increasing to decreasing. So somehow your justification must reference f, and you must show a connection between g and f somehow. Okay. Part C. Find all values of x such that h of x is equal to 0. So they told us that h of x is this integral right here. And they want to know, when is this equal to 0? Okay, there's no work to be done on this problem. You're just going to do this by looking at the graph and coming up with it algebraically. So you have to figure out what can x be so that this integral is 0. If this integral is going to be 0, really what you're looking for is where you have the same area portion above the x-axis and below the x-axis. Okay? First of all, one value that I can come up real easily should be x equals 3. Because anytime the bounds are the same, it's 0. Now let's look at this graph here. So the only point I'm going to is x equals 3, which is right here. Do you notice that this piece is symmetric to this piece, and you have the same area above the graph and below the graph? So if you integrate from 1 to 3, those areas will cancel. So x equals 1, integrating this graph from 1 to 3 will also give me a value of 0 because I get the same below and above and below. Now notice this is also the same as this. So actually if I start from this and go all the way to here, these two will cancel out, these two will cancel out. So also using the x bound of -1 will also make it 0. Okay, again, this problem there's no work to show, you're just doing it by inspection by looking at the graph geometrically. Lastly, they want to know when is h decreasing. H decreasing. So as soon as you see that word decreasing, you should be thinking this. H prime of x is going to be less than 0. Okay, write that down. Well, what did they tell us h of x is? H of x is this. So what is h prime of x? Again, here's your second fundamental theorem. H prime is the derivative of this. So it does the integral. Notice the x bound is on the bottom this time, so h prime is going to be negative f of x. So I'm going to take this, substitute here. Negative f of x is less than 0. This is what I'm looking for. But the graph that you're given is actually f of x. So let's get rid of this negative sign. If you remember from algebra, when we divide by a negative on inequality, it flips the sign. So I'm looking for this. You have the graph of f. Where is it greater than 0? It's only above the x-axis from 0 to 2.